All right. Good morning, students. How are you today? How are you, Jim? Good? All good? Great. Now, students, we want to learn about hypothesis testing. And for the next 10 minutes, I will explain you about introductions to hypothesis testing. I will share you common examples to make you understand about the hypothesis testing. All right. Let's say you will hanging out with Simon, your best friends, and uh, you will you will go bowling with him to the nearest mall, and Simon says that his long-term average is 150. For your information, the score of 150 is really hard to achieve for beginner or novice player. And during playing with Simon, you notice that over 3 games, Simon's average score is 40. And do you believe him? Do you believe Simon? His average score is 150? Or is Simon dodgy? Is Simon a liar? Now, let's we answer this question. Is Simon dodgy? Is Simon a liar? The fact is, over 3 games, Simon's average score is only 40. From this data, you most likely don't believe him. Don't believe his average score is 150. Okay, pretend over 3 games, Simon's average score is 140. Now, how is it? Do you believe Simon? Yeah, I think most of you will believe him because 140 is quite near to 150, and you're more likely to believe him, although the score is 10 below his average. You can consider maybe Simon is not in really good mood. He not really concentrate, or there are 1,000 reasons, but you most likely believe that average score is 150 is no problem. It may be true. So I will separate this class into 2 groups, and let's each class discuss these questions. At what point between 40 and 140 do you make the decisions to believe Simon or not? Yeah, it's just the individual, or it's different for individual opinion, right? I'll give you 5 minutes to discuss, and I will come to your groups to see you guys. All right. After 5 minutes in the group discussions, and everybody come back to this class. All right, guys, how is your opinion? Is Simon dodgy? I will ask 2 students here. First, Rina. Rina, do you think is Simon dodgy? And what is your cut-off score for Simon? 60? All right, 60. So the cut-off point is quite far, right? From 150. Yeah, that's fine. And the second one, I will ask Leo. How about you, Leo? What is your cut-off point? 130? Great. You are very big area for cut-off for Simon. All right. So the basic in hypothesis testing is first there is a claim, and then if a sample outcome falls below a cutoff value based on the assumption that the claim is true, we will reject the claim. Now let's see the normal distribution graphic here. As you can see here, the x-axis is average bowling score for 3 games. From the data, we get the average score from Simon is denoted by mu equal to 150, and the y-axis or the vertical line is the probabilities. You can see here the most likely is the average bowling score for 3 games should be 150. All right. From this picture, we can see the cutoff point is 120. The shaded area or the blue area is the rejection area. We call it rejection area. Let's say we change the subject a little bit. The person you will ask you for bowling is your mom. Now your mom asks you to join for bowling, and your mom says, honey, my bowling average is 150. And you play with your mom and you find the similar situations with Simon over 3 games. Your mom average score is 40. Now it is more tough situations because your mom will because your mom is not easy for you to claim here as a liar, because he will not cook for you for dinner if you said her a liar. And what if you want to be more sure that the claim is false before rejecting it? In Simon's case, you can reject the claim. You can easily blame Simon is a liar or a doji, because, as you know, he sometimes also trick you, and you know he sometimes lie with you. But this is now your mom. So what if you want to be more sure that the claim is false before rejecting it? Yes, the answer is use a lower cutoff value. For Simon, this is 120. For your mom, this is maybe 50. This is the distribution of bowling scores. The x-axis is the average bowling score for 3 games, and you can see here the cutoff point now is 50, and the shaded area is the rejections area. You can see it's more smaller than before. So the probability to reject is quite small than the probability to reject Simons that we see before. All right, from that examples, now we can see the step-by-step of methodology of hypothesis testing. First of the hypothesis testing is, we call it null hypothesis. It is denoted by S0. It is the claim. For the example, Simon claims that his bowling average is 150. The second step is, we call it alternate hypothesis. It is denoted by H1. Here is the counterclaim. For example, Simon's bowling average is below 150 and Simon is a liar. The third step is we define the sample statistics. It is denoted by X. It is the observed sample estimate. From the example, Simon's bowling average for the 3 games you played together is the sample statistic. Critical value or C is the cutoff value that indicates whether the claim is rejected or not rejected. In your mind, you tell yourself, if Simon scores below 120, I will reject his claims. 120 is the critical value of cutoff point. And the fifth step is significance level, is denoted by alpha. It measures how sure you want to be when rejecting H0. Smaller the alpha, the more sure you are when rejecting H0. It is denoted by shaded area, the blue area below the normal distributions that you see before. So you will use a smaller significance level for your mom because you want to make the probability is quite low to reject the claim of your mom, and you will use the bigger significance level for Simons because you want to reject the Simons bigger than your mom. You nothing to lose to say Simon is a liar. All right. The next presentations, I will show you the calculations, the examples for hypothesis testing in our background, in our field, which is in industrial engineering subject. All right, see you for the next presentation, guys. Bye.